Eric Com here with ESI Group's industry marketing team, and I'm going to present to you another version of one of the demos that I presented earlier and recorded and published earlier. And one of the comments that came back to me from one of my colleagues and a few others who viewed the video was, how can we verify that our hands, when we're trying to do this kind of operational clearance check for a service or an assembly process, how can we make sure that not only can we get the object that we're installing in and out of the space that we're concerned with, but how do we also make sure that our hands and possibly even our arms are still free and unencumbered in order to reach into a particular area and pull something out. So we're going to go ahead and take another look at this engine compartment for a heavy machine. This is a wheel loader, I believe, and we're going to go ahead and take a look at what it's like to try to use some tooling in order to access that area and make sure that our hands can get into the area where we need to be, in addition to possibly assembling or disassembling any other types of components. So first things first, again, I've gone ahead and I've taken the time to set up my VR rig so that I could be here in my office and effectively kneeling on top of this tire. So I've just got a crate that I put inside of my office that I have positioned and located its height so that it was a good proxy for the height that I would have when I was kneeling on top of this tire. And now when I reach into the engine compartment, this is a very realistic rendition of what I would feel like if I was leaning into this engine compartment myself. Now, one of the things that we mentioned first is maybe I'm concerned with when I reach in here, do my hands actually fit around or into the areas where we want to do this kind of assembly? And you can see right here in this particular example, I'm going to try to hold my head as stable as possible, but this tool goes in and it's a kind of articulated tool with a U-joint in there that would allow people to get in there and fasten that. However, one of the things I might wonder is, can I get my hand in there and put the fastener in place to stage that? And can I catch the fastener when I loosen it without it dropping into the nether regions of this engine compartment? So one of the things that we do sometimes is I have a CAD model of my virtual hand here. And the virtual hand that I grabbed this from the hand model of a 50th percentile male. So this is a very average size hand, and I also picked a hand posture that's not so different from what I would use if I was trying to grab onto a small fastener. And now when I'm using this little CAD version of my hand, you can see that that is able to collide with the various engineering bodies that I brought into this virtual reality analysis. And what I want to do is I want to see, can I actually get my thumb and my forefinger into the space where that fastener would actually live? And right now, that's telling me that that's not so easy. That's kind of a tricky thing to get my hand in there. So one of the first things that I might do to very simply mitigate this kind of experience is recommend that people should use magnetic versions of these tools. That way, if they are working with a ferrous-based or a magnetic alloy for that screw or bolt, that they'll be able to get that in there very well. But you can see by using this virtual reality hand, when I grab onto it, that CAD hand is displacing the physically simulated objects that live inside of my scenario. Another thing that happens inside of our software that is a user-definable solution is that anytime my virtual hand is grabbing onto things, I can also tell my virtual hand to collide as well. So in this case, you can see that it's not the red CAD-based hand that's displacing that cable, but is in fact my VR hand. And that VR hand, I can tell it to allow it to not collide with objects, but only collide with objects when I'm grabbing onto something. And that gives me a very pragmatic, very easy way to verify how much room I have for clearance inside this area. Now when I'm using this tool, if I was grabbing onto this tool and I wanted to get this tool in there, you can see that by holding onto this tool, now my hands are collidable objects. And when the collision of the objects is making my virtual hands go too far away from my actual physical hands, you can see that I'm getting this ghosting reaction where I have a ghost version of my virtual hand floating here in space, and then I have the VR version of my hand, which was down here. So that anytime that collision caused my virtual simulated objects and my real hand motion to track separately from one another, then I got a very easy representation of this object cannot go any farther. It's being blocked, but I can see that ghosting happening. So now when I try to push my virtual hand in there, you can see that that virtual hand is blocked and it stays put. But in the meantime, in VR, I continue to move, and I'm getting a good representation of my actual hand motion relative to my avatar or my digital version of my hand in that simulation. Hopefully that's helpful and answers the questions for those of you who posted that question on that video link that we shared before. And I look forward to answering any other questions with additional demos coming soon.